quadratic, which you may think you already know all about. But we're on our way to something much bigger. And to do that, we got to go back to the distributive property, but maybe I'm going to explain the distributive property and you have a more open mind about it where you go, oh, there's more to the distributive property. There's not more to do. There's not more to do. Distributive property will be the same work you did before, but there's more to understand about the distributive property. There might be times in this lesson you're like, oh, I didn't really understand the depth of the distributive property. Here it is. Learning goal, determine the product of two binomials. What? Determine the product of two binomials. We'll get to that in a minute. First, the product of two things where only one's a binomial. That's what this is. Binomial meaning two terms. So this is a binomial. And all that means is it has two terms, like a bicycle, two wheels, okay? We called this fancily in grade 9 multiplying a monomial by a binomial. But do you remember this? I just draw the little arrows. Whatever's out front gets multiplied by both things. Here's my deeper understanding, though. This is like BEDMAS plus. BEDMAS says do what's in the brackets first. BEDMAS refuses to negotiate. It says do what's in the bracket first. And then you get something with a number out front, say 3 times x plus 2. And we can't add what's in the bracket. So if we were in an argument with BEDMAS, BEDMAS says add what's in the brackets first. We go, I can't. They're not like terms. Distributive properties outside going, psst, hey, if you don't want to do what BEDMAS is saying, watch this. I can not break BEDMAS, I can add on to BEDMAS. So it's BEDMAS, yes, if I can. If I can't, distributive property. That was the explanation of grade 9. But let me go a step farther. This is about mental math as much as anything. You ever met somebody who can do crazy mental math? They're not smarter than you. They just have some strategies. For instance, when I see 7 times 14, I don't try and do 7 times 14. I don't go 7, 14, 21, 28, 35, and count 7 14 times. I have this picture in my mind. Literally, a picture comes up in my mind that looks like this. 10 and 4, because I can do 7 times 10 in my head. It might be one of the easiest multiplication questions there is. 7 times 10 is 70. Now, if you can't do your single digit times single digit multiplication in your head, well, okay, I'm sorry, you're out of luck mental math-wise. You've got to get that part down first. Because what's 7 times 4? You can decide right now. I either know that, or I'm like, 7, 14, 21. See, no. No, we need those. We need up to 9 times 9. Like that. Well, not like that, but at least like 28. And now 7 times 14 is 98. That's the distributive property. It's going, I'm not going to multiply 7 by 14. I'm going to multiply 7 by 10 and then add on the 7 times 4. Very powerful stuff. We use it all the time in algebra, but also good for mental math. That's what it looks like. But maybe this makes it look confusing. Like, I thought I was good at distributive property. That looks confusing. It often is when we use the letters like that. Let's jump right in and do one. The grade 9 version of this. 4 bracket x plus 3. Draw the arrows. Even if you were not an arrow person, because you were so good at it by the end, you might want to draw arrows today to get used to our new distributive property we're going to do here. So you go 4 times x, which is 4x, and 4 times 3, 12. Is it okay? Because I'm going to teach the rest of the lesson like you're looking at this like, really? I got up early here on Tuesday after Easter for this? No, you did not. This is just me going, are we okay? We're okay here. We're okay? Trying to make eye contact with as many people as I can. Get some nods. I'm weak from Easter. I can barely nod. Can you nod? No, it's okay? Okay, let's make it a little harder. What if it's x times 5x and x times 7? What's x times 5x? And get ready. I'm going to ask you why. If you get it right, okay, here. So you're ready. If you get it wrong, I'm going to look up and look back and then think about what I'm going to say next. If you get it right, then I'm going to ask you to explain. What's x times 5x? 5x squared. He says 5x squared. He is so right. But can you explain what you think about to go x times 5x is 5x squared?
Well, when you square something, it's times
Yeah, he's actually sort of using the commutative property. He's looking at it and going, let me put a thought bubble down here, just in case anybody has trouble with this. He's going x times 5x. And he's looking at that going, what's going on here? Maybe, actually, he probably didn't think about it for too long. His brain sort of rearranges and goes, it's hard to get your brain to slow down enough sometimes to figure out, what was I thinking about there? And that's why you'll see me hesitate in the middle of a lesson. All of a sudden, I stop and I go, okay, let me try and explain my thinking. And it takes a second. But what he's doing is going, okay, well, I'm going to multiply it in that order instead. And instead of going x times 5 times x, the x and the x can be maybe grouped together. X and 5, there's not much I can do there. And he says when something gets multiplied by itself, x times x we write it as x squared. So that's really what's going on. And I take time for that not to re-explain what you learned in grade 9, because that's the part that's probably going to mess you up today. When I show you the distributive property for two binomials, you're not going to think much of it. But this kind of thing is what's going to mess you up. And what about x times 7? Well, those aren't like pieces, so they can't be grouped together. So we just write 7x. We usually write the coefficient first. Writing x7 is not incorrect. It's just that we don't talk like that in math. We put the coefficients out front. Is that okay? So then how about this one? Another volunteer, because this is one step more difficult. And I'm telling you, this is the lesson right here. The distributive property is not going to be too exciting to you. Really. It's going to be this stuff that messed you up. What do you like? 15x squared. Now, what did you do there in my Halloween writing there? Let's do a thought bubble there. Because you guys are great poker players. I can't always tell. Some of you nod. Some of you lazily do nothing. So I can't tell. Maybe you're out there going, I don't get this at all. So this is the extra explanation. When you went 5x times 3x, can you figure out what your brain did to that? Yeah. Your brain really goes, okay, I'm going to multiply the 5 and the 3, then the x and the x. Multiplication is very friendly. Actually, it's my favorite operation because it's very friendly. It allows you to change things around and go, okay, well, can I multiply it this way instead? And yeah, you can. And then so then I get 15x squared. And if you have to write something like that down tonight when you're doing this homework, good. That makes you a good mathematician when you know when it is a time to go, hold on a second here. What's going on here? And then 5x times 5, you think it as 5 times 5. Multiply the coefficients. And x has nothing to multiply with, so it's still just x. So instead of 5x times 5, it's 5 times 5 times x. Multiplication, very friendly. It goes, yeah, you want to multiply them the other way around? No problem. Actually, when you're learning your multiplication tables, you find this out. There's a bit of a treat that happens there. Once you learn 4 times 6, when 6 times 4 shows up, you're like, same thing, yeah? Nice break, yeah? Any questions there? We need those good. Is it good? I'll take more time. Okay. If we've got that, the next step is no big deal. Okay. It's confusing the first time you see it. So let me give an example before I put it up on the board. Let's imagine for a second that I come driving up in my car. It's me and my son Bennett meeting you and one of your friends. We're all going to meet at the park because we're going to play some basketball. And everybody's going to shake hands with everyone they haven't met before. So I get out of the car and I shake hands with you and with your friend. And I got to shake hands with my son. I just drove here with him. I don't need to shake hands. Bennett gets out of the car, shake hands with you and with your friend. That's distributive property with two binomials. That's all. Okay, here's some fancy pictures to show it out. But again, if the fancy pictures mess with your brain, don't worry about it too much until I actually do an example. If you've got A and B, so that's in the first car. My son's name is Bennett. My name's Alan. It's not. Alan and Bennett in the first car. Chloe and Deirdre in the second car. What are all the handshakes that have to happen? A and C. A and D, B and C, B and D. That's what's going on there. No one memorizes like this, by the way. Nobody. Nobody memorizes, oh yeah, AC plus AD plus BC plus BD. No, this is just how we explain things in math sometimes to go, where do all the letters go? Some people just do this. See this all the time. Even with AP Calculus students, you see them drawing the arrows to go multiply everybody in the first bracket times everybody in the second bracket. But I can't resist doing a mental math one. I can't resist. Because you might go, oh my goodness. That is insane. Let's say you wanted to do, say, what's a little bit bigger? Some of you might have done up to 12 times 12 in your head, yeah? So something slightly bigger than that. 13 times 15. Yes? Here's what it looks like. And this isn't me playing around. This is a great picture of binomial distribution. The 13 I think of as 10 and 3. And maybe I do a better picture by making the 3 smaller. And the 15 I think of as 10 times 5, 10 plus 5. And each rectangle is easy. 10 times 10? 100. 10 times 5? 50. 10 times 3? 30. 3 times 5? 15. Answer? 195. Now, you're like, is that really how you handle that in your head, Mr. Todd? The answer is no, I'm a little better than that. And not because I'm brilliant. I may be brilliant, but it's not because of this. Once I've practiced the other one, the single times double enough, I can do single times double, single times double. I have a little bit better version of it. But when you're learning to do mental math, if you really want to be better at mental math, this is good. 10 times 10 is 100. 150, 180, and 15 is 195. That's pretty fast for double digit times double digit. And it works for all double digit times double digit. If you incorporate this into your thinking, doing up to 99 times 99 in your head is quite possible. Just like, boom, answer. Okay? So, mental math strategies are the key, not brilliance. Strategies. And this is a great strategy. That's what this was saying. Everybody in the first bracket gets multiplied by the ones in the other bracket, and and vice versa. But nobody memorizes it like this. This is just what's going on. Many people memorize this part though. They choose this. It's called FOIL. I don't know if you've ever heard that word before. FOIL is a shortcut to remembering what has to multiply together. I'll try and do both at once. I like the arrows, but I'm going to teach FOIL as well because some of you might like FOIL better. And FOIL means multiply the first two things together. So in my silly drive to the park example, that would mean multiply the two drivers together. Then the outside people, that means this driver with that passenger. Then the insides, that's my passenger with your driver. And then the last, which is the two passengers. So the FOIL just helps you remember which ones you're doing. Again, I don't know too many people who actually go through the steps of FOIL. They just use FOIL as the catchphrase to know how to do this. All right, shut up, Mr. Todd, do one. All right, I'm with you. Do one. Here I go. Here's with the arrows. You want to expand? Why are we expanding? Hold on, why are we even doing this? Actually, I don't want to teach you expand. I want to teach you factoring. I want to teach how to take a quadratic and put it into factored form because we found out factored form was better. To do that, I first have to teach you how to expand. I teach you how to go this way, and then we'll be able to figure out how to go the other way. All right. So, all the brackets. X times x. X squared. That's the first ones. So that's the f in FOIL. I took the two first terms, I multiplied together. Then I multiply the outside terms. X times 5. 5x, yes. Then the inside terms, the arrows show multiply the inside terms, but in FOIL, inside, that's 2x. And then the last term, 2 times 5 is 10.
You add all those together?
I can add all those together. Usually there's some combining I can do there. Usually there's at least one combining. And I see there's a combining that I can do there, the 2 and the 5. And for us, a lot of times, it'll be the center two terms can be added together and simplified out. If you're seeing big picture, you're like, oh. So if I'm in factored form and I want to get to standard form, this is all I have to do. Multiply the brackets, and then I'll have standard form. If you're 2 steps ahead of us, you're like, this isn't what I want. I don't care about this. I want to be able to go to standard to factored. Yes, another lesson coming on how do I get from standard back to factored form. It's not that hard, but we got to do some thinking before we do it. All right, what can go wrong here? Negatives, as always. It's always negatives that messes you up here. So very carefully, through all the steps here. X times X, that's the first terms. That's what F stands for in FOIL. And here, no harder than the previous one. X squared. Then the outside terms, the X and the 6, I get plus 6x. And here, I don't know if this is going to cause you a problem or not. Now I'm multiplying the inside terms. That's a negative 5. You're like, well, no, I don't know. Let's subtract 5. I'm like, yeah. So someone says, hold on. For the record, Mr. Todd, that 5 right there, is it subtract 5 or is it negative 5? Listen carefully to the answer. The answer might mess up your whole day. Say, is that 5 negative or is it subtract? My answer, yes. You're like, wait, are you not listening to me, Mr. Todd? Let me say it again. Stop messing around, Mr. Todd. Is that 5 negative or is it subtract? My answer, yes. It's either negative or it's subtract, depending on what you want to do. I look at it this way, and I'm not joking around. Say, Mr. Todd, are you a dad or are you a teacher? I'm like, yes. That depends on what's going on. I can do either, all day, every day. Right now, I'm standing here. I can be your teacher. If I get a text message from my daughter, I just smashed on my car, I'm immediately dad. Yeah? Whatever needs to happen. So here, if I knew what X was, I'd subtract 5. If I'm multiplying, I'm negative 5. And that's okay. It really is okay. Here's how it's really okay. If you really want to understand the really advanced version of this, technically you got to think of it as X plus negative 5. Then it actually is negative 5. Then you can multiply it and switch it back to subtract it. No problem. No trickery. No magic. You just have to think of it as adding a negative. All right. Oh, anyways, after all that, it's negative 5x. And then negative 5, and then the last. Multiply the last terms. Negative 5 times 6 is negative 30. And when you do these, virtually every time the middle 2 terms will combine. Can I make up a question where they don't combine, where other things combine? Yes, maybe. But for us, most of the time, those middle 2 terms will combine, and I get 6 minus 5 is 1, which you can write the 1. It's not incorrect to write 1, but you can also write it without a 1. Well, let's not wait around to tonight to find out that part of the lesson's a problem for you. And I noticed some people up here already way ahead of me, already doing a bunch of these, because they're fun, actually. I thought you might like them. This kind of algebra is sort of nice. Is there tough algebra coming? No, not too bad in grade 10. You know, nice algebra in 10. Try this one, and I'll share the answer while you're doing it, and then you can look up and see if you did it right. How'd it go? Did you get x squared minus 7x plus 12? Can anyone sort of see how we might go backwards? I don't want to get ahead of us. As we're doing these, sort of look at it and go, could I go backwards? Could I figure out what the numbers are by just looking at what's going on? Let that bounce around your head, because I got to teach that at some point. And if you're ready for it, it'll be the easiest day, easiest lesson ever if you already see, oh, I can see how you could figure this out. Okay? More of that coming later, though. Any other tricky ones? Oh, yes, here we go. Each one more trickier than last. Yes? This one doesn't look tricky. X squared minus 5x plus 5x minus 25. That doesn't look tricky at all. That's not a big issue. But what happens in the middle here? Negative 5x plus 5x? No x's. And you end up with this, which is one of those situations that's so easy it's hard. When you first see it, you're like, it's not, where's the middle term? You're like, well, it's 0 if you want, or you don't write it. And that can mess you up when you first look at it. But it's actually a pretty simple situation. Yeah. After that, it's just doing what I did before with coefficients. So very slowly now. 2x times x. Who's got this? 2x squared, because I think of it as 2 times x. And that's okay to have that intermediate step. And I think the rest is no harder than the previous one. 2x times negative 7 is negative 14x. Negative 1 times x is negative 1x. And negative 1 times negative 7 is positive 7. Yes, still the combining of the middle two. 2x squared minus 15x plus 7. And those of you who had it figured out how to go backwards, going backwards with these ones, not so easy. Whole separate lesson when we go to do it. We'll do one lesson on how to go backwards on ones that are just x squared, and then how to go backwards with ones with a coefficient. Very difficult. Yes? And you don't have to do that yet. Don't think, oh, Mr. Todd's trying to challenge me. I got to try and work on this night. No, no. Just put it out there. That's what we really want to accomplish in all this, is how do we go backwards? All right. Well, let's not wait around. Here, you try another one. You try F. See how it goes. On page 6 of 7. I'm almost done. It's exciting, isn't it? Because you're tired of listening to me? Is that why you're excited? No, that's not the reason. 2x times 3x. 6x squared. Yes? Then, ooh, I'm not writing the arrows. I encourage you to write the arrows so you don't miss anything here. 2x times 3x. 2x times 2 is 4x. 1 times 3x is 3x. And 1 times 2 is 2. And again, we get this combining in the center. I'm not making a rule that it happens every time you multiply binomials, but something probably will happen. So take a look at the terms and combine the ones that can. Good so far? Someone raised their hand. Mr. Todd, that's not how the ones they look. That's not how they look. They all had a coefficient out front. What do I do if there's a coefficient out front? Well, me personally, I leave the coefficient to last. I've seen people do it the other way. I've seen people multiply the 3 into the first bracket and then do the FOIL thing. So I'm going to challenge myself to do it both ways. And you can choose, okay? I'll do this one way, and then I'll do B the other way. I like this way, but I don't have a good reason. I don't have something I can tell you, oh, you better watch out, better do it my way. This is just my habit. My habit is to leave the 3 out front and then do the FOIL. I'm trying to use that word because you'll hear people use that word all the time. Even though they're thinking with arrows, they say FOIL. So everybody knows what they're talking about. And so I just do this part first. Because multiplication is friendly, and I can do it whichever order I want, so I take care of the FOIL first. That's me. I think it keeps the numbers smaller. That's what I like about it. Then I do the combining. And then when I'm all done, I distribute the 3 out. It keeps the numbers smaller. I guess that's what I like about it. So this 3 gets multiplied by each of these terms. So I get 3x squared plus 33x plus 90. Is that okay? The other way to do it is to multiply that first bracket in first. Is that just do this distribution first. And you get the same answer if we both don't make a mistake. And so I multiply that negative 2 in, and then this first bracket becomes negative 2x minus 2. And then I just do FOIL with what's there. That might look simpler to you. And if you like it that way, no issue. I don't have anything to try and convince you otherwise. That's a good way to handle it. And now I do the full FOIL here. Negative 2x squared plus 18x minus 2x plus 18. Now I did that a little faster on purpose, not because I think it's so easy, but because I wanted to stay focused on the idea of this example. And the idea is just make a decision. Multiply the coefficient into the first brackets and then go, or FOIL first, then multiply by the coefficient. So negative 2x squared plus 16x plus 18. I almost wrote minus 18 there. Is it okay? Most people like FOIL. Yeah, most people are like, hey, I can FOIL. That's no problem. But just watch out for that coefficient, okay? Questions?